Welcome everyone to this video on JK flip-flops. As you remember, a flip-flop is a device that has a data input such as J and K here and a data output Q as well as a clock input CP. Our data inputs are J and K and they can take on logic values of either a 0 or a 1. Our output is Q, and it too can take on either values of logical values of 0 or 1. And our clock input is CP, and it will determine when the Q output takes on its value. We will talk more about it momentarily, but for now it either has a active transition of a positive going pulse or an active transition of a negative going pulse. Again, we will do more on that in a moment. Let's talk a little bit more about the different modes of the flip-flop. For example, there are four possible modes, states if you want to call them that, of this flip-flop. And they are based on the J and K inputs, obviously, and on the transition, in this case, of the clock pulse. And all of those affects the Q output. Alright, so now let's work on the different modes. We'll start off with the mode that exists when both J and K are 0. This is called the hold mode. And when we get an active transition of the clock, and we'll use a negative transition here, then that means that the output Q makes no change. And what that means is that if it was already a 0, it remains a 0. If it's already a 1, it remains a 1. It just doesn't change. Alright. The next possible mode is when J is 0 and K is 1. And this is called the clear, or sometimes reset mode. And once you get an active transition, then the Q output always goes to 0. The next state is when J is equal to 1 and K is equal to 0. This is called the set mode. And once J and K are set to those values and you get an active transition of the clock, then the output Q will always go to a logic 1. The final state is when both J and K are equal to 1, and this is called the toggle state. And when you set J and K both equal to 1, and then you get the active transition of the clock, if Q was a 0, then it's going to change its state to a 1, and if it was a 1, it's going to change its state to a 0, or toggle. Okay. That's basically how the JK flip-flop works there. Now let's talk a little bit about the clock pulse. We need to talk more about how it actually works. Well, if you'll take a look, there's a couple of different ways that it can function. So here we got just the Q output, and then we have the clock input. Alright, now if you have the clock input and there's no triangle here, you just simply have the clock coming in, okay, then this is called a level activation, okay? And what that means is that once the J and K inputs have been set to values, okay, then the clock comes along and it goes to a level state. Notice that it was a 0 here and then it went to a 1 here. Well, during this period of time here, the clock is level. That means that the Q output will take on whatever values that J and K forces it to be. For example, let's just say in this situation that J is equal to a 1 and K was equal to a 0, and the original Q was equal to a 0. Then when the clock is applied and it reaches the level, it reaches a level state, then that means that Q will now become a 1. Because taking you back just briefly here, now look, J is 1, K is 0. So if you look at a table here, when J is 1, and K is 0, then this is a set state, and the Q output goes to a 1. Okay? Alright, so back to our example. Then that means that if Q was originally 0, then it's going to go to a 1. So the concept here is that this is a flip-flop with a level activated clock. Okay? Now, we also have flip-flops that are activated by what we call the transition of the clock. Again, we have our Q outputs, we have our J and K inputs. They don't change. What they do does not change. The symbol now goes like so. And this is my clock pulse. So I've added this triangle here. This triangle now indicates that I've got a edge triggered device rather than a level triggered device. Okay, well, where are the edges? Well, okay, here. All right, here's my clock pulse. So this is my clock pulse. Now I actually have two. Here's one edge, and here's the other edge. Now, this is called my positive going transition, PGT, positive going transition, and this is called my negative going transition, or NGT. All right. Now, the symbol I have to the left represents the positive going transition. Okay. This one. All right. So that means that this flip-flop will respond based on J and K to the output will change based on inputs when the positive going transition occurs. For example, let's just say that that Q starts off and Q is equal to a 0. All right. Let's say that J is equal to a 1, and let's say that K is equal to a 0. Very similar to what we did before. Taking you back to our transition table, or to our table, that's this state here. That's this state here. J is 1, K is 0. So it's going to be set, so the Q is going to be going to a 1 when we get the active transition of the clock. Okay, well, what does that mean? Well, here we go. In this particular flip-flop, the active transition is the PJT. So that means when the clock pulse comes along and it does the positive going transition, which would be this, then the output is going to change. And it's going to change to, as it did before, to a 1. Okay? Now, contrary to that, then, or in addition to that, whatever you would like to say, we have the other transition, which again gives me a Q output. Okay? And again, I have my J and my K input. I have my level indicator, but then I'm going to add a bubble here to the clock. Okay? This makes this a negative going transition, or it activates to the, or rather the flip-flop responds to the negative going transition here. Okay? So if using the same example here, if Q was equal to originally 0, and we set J equal to a 1, and K equal to a 0, and we brought the active clock pulse along, all right, clock comes along, goes up, nothing happens, and then it comes down, then this is the NGT, or negative going transition. This would cause the Q output to change from a 0 to a 1. Okay? And that's how that transition works. The level works in a transition. We will probably deal primarily with the edge triggered, which means we'll deal with the positive going and the negative going pulses. So anytime you see the little bubble in front of the triangle, that means that we have an edge triggered and it's a negative transition that triggers the device. So let me do just a couple more things here so make sure that we understand how this process works. So let's take a couple of examples. Let's assume that Q is equal to 0, and let's take J equal to a 1 and K equal to a 0. Yeah, I know you've seen it before. And then we get the clock pulse. Okay, we'll use a let me just draw you a little, oops, it's a little tight here, but here, so this is my circuit. Here's my J, here's my K, here's my clock, and here's my Q output. Okay, so this is what's going on. So now, when I get the active transition of the clock, which will be negative going, which would be here, okay, then that means that Q would go from a 0 to a 1. That's because J is equal to 1, K is equal to 0. Taking it back real quick to the transition table, same one that we've been working right here. J is equal to 1, K is equal to 0, so that sets the Q output, or Q becomes a 1. Let's look at another one here. Let's say that Q is equal to a 1. All right, J is equal to a 0, K is equal to a 1, and we get the proper or active clock pulse, meaning this type of thing here. All right, so now what happens to Q? Well, J is 0, K is 1. Looking at the table, J is 0, J is 0, K is 1, so that must be clear. So that means on the clock pulse, we're going to get Q going to 0. So back to the example. Then we could see here that when this occurs, then Q was a 1, it now has to go to 0. One more example, and we're done. All right, let's say that Q is equal to 0. Now we make J equal to a 1, and we'll make K equal to a 1, and we get this good old active clock pulse. All right, again, we'll still continue to use the negative going transition. All right, so now what happens to Q? Remember, J is equal to 1, K is equal to 1. So let's go look at our transition table here. Okay, one more. There we go. All right, so we've got J equal to a 1. We got K equal to a 1. That's our toggle state. So we get the active transition. Now what happens to Q? Well, if it's a 0, it goes to a 1. If it's a 1, it goes to a 0. So let's go back to our example here. All right, so here we got J equal to 1, K equal to 1. We get the proper active clock pulse. So that means that since Q was a 0, it's got a toggle. So it's got to go to a 1. So it would toggle from 0 to a 1. All right, that is the video on the JK flip-flops.